Hi friends, welcome back. My name is Ajay Dwivedi. Today we are going to talk about the fifth dashboard in SQLMonitor tool. To give you a recap, SQLMonitor tool is an open source tool that is designed using PowerShell and native T-SQL or Transact SQL, which is inbuilt language of Microsoft SQL Server. This tool I designed for the purpose of setting up baseline for SQL servers that I monitor, and eventually I ended up making it a robust tool. It is entirely free, so if you want to deploy it in your production environment, there is no licensing restrictions. You can freely deploy it in your production servers or even in your personal lab or laptop. So let's go ahead and look into the details of our fifth dashboard in SQLMonitor tool. So you go back to your Grafana dashboards, Grafana tool. In the Grafana tool, you open the SQL Server folder. If you follow the instructions, then you will have a SQL Server folder under which you must have imported all the dashboards that are part of SQLMonitor infra or SQLMonitor tool. So today we are going to explore this last dashboard, who is active SQL Server queries workload. This particular dashboard has around 6 to 7 rows in it. Couple of rows, they give you the active workload that is running on the server, active queries or sessions that are running on the server, and some of the rows have panels which give you the information about what was running at a particular time frame, whatever time frame you choose from the drop down at the top right corner. So let's expand the first panel, first row. As you can read the name of the row, it says what's running. So this anything which is appearing in this row, any panel, all the details in this panel which is appearing in this row which says what's running, it is always the live data on that server. So if I choose my server to be SQL Practice, which is my general server where I run all the workloads and testing, here you can see at a moment, that means right now, there are 3 sessions running on the server. The first session ID 68, it has been running for around 8 minutes. The second session 67 has been running around 7 minutes, and the third one around 3 minutes. You can see how what kind of query they are running. You can see how much memory has been granted to those queries. You will see the client application which is running those queries or sessions, login name, database name, what query exactly is being run in those sessions. So those sessions are running this stored prop. Probably this is the right time I should tune these stored prop or queries. Apart from this, you get other basic details also, like how much logical reads these sessions or requests have done, how much writes, CPU time, open transactions, what host these sessions are coming from, and all those basic details. So this is the first row which gives you the live information, whatever is running on the server. This row is very important because we cannot give the full access to application folks or developers on the production servers. But if they want to find out why their application queries are stuck or what they are doing, you can redirect them to this dashboard, and they can look whatever their session is doing from this first row details which are here. Let's talk about the next row. So that in this second row, as you can guess by the header, again we are exposing almost real-time information about what is running on the server. Why I said almost? Because this information is coming from recorded information which we got from running sp_who is active. So sp_who is active is an awesome tool, a stored prop designed by Adam Mechanic, which has a lot of parameters to get whatever various kind of results that you are interested. In our SQLMonitor tool, we are utilizing sp_who is active extensively, and we capture variety of information like execution plans, we capture additional information, so transaction information. So lot of things we capture using SP who is active. We by default we run SP who is active capturing every 2 minutes. So that's why I said almost in real time. If I refresh my screen, you can see the latest capturing that we have is of 22:38. That means 10 p.m. 38 minutes. Right now that is the exact same time. So pretty much at max 1 to 2 minutes of delay, you will get whatever is running on that server captured through SP who is active being shown here on this particular row or panel. So according to who is active, the capturing happened at this time 22:38 11th second. These many sessions were running. These were the duration for those sessions. These were the logins which were running those. These were the client applications and logins that were running those sessions, and you will see all the basic details regarding those sessions. The third row, as you can guess by the name once again, shows the whatever is running live on the server in terms of DBA maintenance. So DBA maintenance include backups, check DB, update stats. So if there is any kind of DBA maintenance running on the server, that will appear here. As usual, like with the previous row, this information again is coming from captured data of SP who is active. The latest capturing happened at 22:38. So if there happened to be any result appearing in this panel, that would be of 22:38 time frame. The fourth row again shows similar information, but in this row and inside this panel, we will only see the sessions which belong to SQL Server agent jobs. So, for example, in my current organization, many application activities run through SQL Server agent jobs, and all the time we DBAs receive requests from application folks, from developers, saying that, hey, can you tell us what is going on with this job, whether the job has started, what the job is doing, whether it is stuck, whether it is blocked. So we are exposing whatever job is running on the server at this moment, that is 22:40, 10 p.m. 40 minutes. At this moment, whatever jobs are running, they will appear in this fourth row inside this panel. Now the header of this fifth row has changed. As you can see, long running queries. So what it is saying is whatever long running queries were running between this time frame. So in last 30 minutes, whatever long running queries were running. Oh no, sorry. It is not about in last 30 minutes. At this moment, whatever long running queries are running, this particular row or panel exposes that information. Now, the excellent question that comes, that happens to be here is, what do we mean by long running? So long running here means whatever queries have been running for over this duration. So right now we have set a duration of 5 minutes. So whatever sessions or queries have been running for over 5 minutes, they will appear in this row or panel. So for example, if I change it to 8 minutes, we should see only one of them. So there we go. Now we only see one of them, because in this case now the long running means 8 minutes. So I think even those sessions completed. That's why we don't see any long running anymore. The last row exposes anything which has been running between this time frame, whatever time frame we have selected. So for last 30 minutes, these sessions have been captured using SP who is active. The latest capturing is of this time, that is 10:42 p.m. So for the last 32 minutes, these are the sessions that have been running and have been captured using SQL is active. You can see here the latest capturing is of the latest capturing that is appearing in this panel is of 22:40, and before that the earlier snapshot was of 22:38. So in short, we are running SQL is active and capturing workload information every 2 minutes around. So for the last 30 minutes of duration, these are the sessions which have been captured in SQL is active. So that's it all about this particular dashboard. As a bonus, I have been running a general workload on my SQLMonitor on this SQL practice SQL Server instance. So let's see how this looks like for the how that workload looks like today. If I change this to last 12 hours and we look for the CPU utilization, there you can see my server has been up and running for entire 12 hours of duration, as we can see the metrics here. But my general workload started, some kind of workload started around 1 p.m. on this server, and that have been pushing the pushing the CPU on the server to 100% quite often, but on average it was still below 60-70%. Now, but there happened to be some issue on the server around 8:35 p.m. So between 8:35 p.m. till 9:32 p.m. we had almost 100% CPU all the time on average. So for 1 hour of duration we had around 100% CPU. So what we are going to do is we are going to find out what has changed in this hour compared to yesterday that caused this high CPU issue. So there we go. Now you can see the average CPU at the operating system level for this duration seems to be 81%. SQL Server CPU seems to be 74%. If I can choose more precise time frame, then the average will go up. So there we can see now the operating system CPU happened to be 88% for this duration. In order to find out what caused this high CPU, so let's note down the time. The time is 20:37, from 20:37 today till 21:29. So let's see what changed today compared to yesterday in terms of workload. For that I have designed multiple queries. Right now we don't have any dashboard where we are exposing this information, but apart from capturing SQL is active information every 2 minutes, we have even extended events being deployed as part of this SQLMonitor tool. So if you go to management, extended events, sessions, you will see one extended event session which is resource consumption. So in this extended event session we are capturing RPC completed and SQL batch completed events. So let's talk about our current scenario. So what I am going to do is I want to find out, since CPU is my issue, so I want to find out what is the difference between yesterday workload between today and yesterday, which caused high CPU. So in the same SQLMonitor project that you download from GitHub, under SQL queries folder or project, you will find this query RC, that is resource consumption, workload delta by CPU. Choose the particular server that you are interested into. Choose the database where you are saving the information. Now we want to compare snapshot 1 against snapshot 2. Snapshot 1 would be yesterday's date Snapshot 2 would be today's date. The time frame would be around 8:37 till 21:29. So instead of 8, it would be 20. This one would be 21, 20, 30, you can say. So I'm going to paste the same information here. So there we are ready with the query. In this query, what we intend to do is, we want to find out in terms of CPU, what kind of workload was running between 8:35 p.m. till 9:30 p.m. today, and we compare the same logins for the same time frame in yesterday's workload to find out whether their CPU usage has gone down or up. So something is wrong. Snap 1 start time should be 20:35. That is correct. Snap 2 should be, snap 2 time should also be the same thing. Start time should be the same. End time should be this one. So this is how the information should like. Start time for both the days should be 8:35 p.m. End time for both the days should be 9:30 p.m. Now if I run this query, here we can see during this time frame, today and yesterday, only 2 logins have been detected, which have been captured in extended events. So in these extended events, we are capturing any requests or any batches or RPC events which ran for longer than 5 seconds of duration. So after a session has been captured in extended events, now we are comparing those captured sessions which were running between these durations, and we want to see whether the CPU workload has increased or decreased for those. So let's start with the top one. Top one is saying there has been a user, SQL login user, SQL query stress. In the snapshot 1, which happens to be yesterday, it had no CPU usage at all. So that means yesterday this workload, that means workload for SQL login, SQL query stress, did not even exist. There is another login or user, which is Ajay Dwivedi. That user was present yesterday and even today. Yesterday it did a CPU consumption of about 6 minutes. Today it did a CPU consumption of about 33 minutes. But still, since we are talking about high CPU duration of 1 hour, so definitely this particular login or workload entirely cannot be responsible, because the entire CPU utilization is not around 1 hour. Rather, this one, the workload for this login SQL query stress, which was not even existing yesterday, consumed 1 hour 43 minutes of CPU time today. So this is how we find out what login is causing the high CPU on the server, or what login caused the high CPU on the server. So if my clients or application folks or developers come reach out to me saying that, hey, there was a high CPU for this duration, or if as a DBA during RCA I want to submit what caused this high CPU, then I run this query. This query analyzes the data captured by extended events, and it gives me nice information about what logins were running, how much CPU they did yesterday, that is snapshot 1, how much CPU they did today, and whether it has increased or decreased. So you see, if you see a plus sign over here, that means the CPU workload compared to yesterday has increased. If you see a minus sign there, then that means the CPU utilization today has decreased. So that query or that login should not be the cause for high CPU. So today we can see increase of CPU in both of these, for both of these queries. Where is this being represented here? CPU time, yeah, here. So this is the column which is saying that information. So here we are saying that for this login SQL query stress, it is a SQL login, then the CPU utilization has increased by approximately 2 hours compared to yesterday in this time frame. For this login, CPU utilization has increased by 27 minutes today compared to yesterday. So this is the information that I will share with the application folks or whoever owns these logins, and we will suggest to them the top queries that they should tune in order to bring their workload, to bring down the CPU utilization caused by these workloads. So thanks folks. That's it about this fifth and final dashboard that we have. In future we will add lot more dashboards because there are a lot of open enhancements that are there in this, that have been logged in this SQLMonitor tool. Come on man, load. So with those enhancements, a lot of new dashboards would be added into this Grafana. For example, whatever we just talked about in SQL Server Management Studio, that kind of analysis we will get into the Grafana dashboards in future versions. We want to visualize the same information in histograms and time series graphs so that we can see for which login and program how much utilization have been there 3 months back or yesterday or day before yesterday or in last 15 days automatically through the Grafana dashboard. Right now I am utilizing the queries, but in future versions we will have Grafana dashboard for all those kinds of things. Similarly, in future we will be exposing the SQL Server statistics information for about tables on Grafana. We will expose database and index and table level space utilization or index usage information on Grafana. This space utilization we are already capturing and exposing on Grafana dashboard, but we are not exposing the trend information about the disk space usage. That will also appear as a separate dashboard in future versions. So pretty much there are a lot of enhancements yet to be done in SQLMonitor infra that would make this tool really useful and as compared to the enterprise grade software. So I hope you guys like this tool. If you like my videos, kindly like it on the YouTube, share it, and stay subscribed. Thanks for joining.